Hi everyone, thanks for joining. I know we're still waiting for a few more people to jump on, so we'll give it a couple of minutes. I'll just run through, obviously, a bit about agility and a bit about what happened on the first session that we've had as well. Obviously, some of you, this is your first time joining us, so I'll just do a quick overview of agility and what we do. Vertex Agility is the consulting arm of Vertex Solutions, which most of you probably know is primarily a recruitment staff augmentation business. So over the last couple of years, we've been providing mostly remote support to our clients, but we're doing remote and on-site solutions at the minute. Again, really depending on the customer and where they're based. So we support people that are, well, we support businesses that are in Europe, we support businesses in the States, we've done a bit of work in APAC too, so it really depends. I guess you could say that our niche is that we build bespoke, pre-verified teams to fit an exact need rather than body shopping or shoehorning people into a role. A lot of the people that we work with, we've worked with in the past with other customers or, on other projects, so we know that they're good at what they're doing, we know that they're obviously trusted. The employed consulting model that we have has proven to be quite successful, obviously with the changes that we have here in the UK with our 35 and stuff, and also obviously we do a lot of work in the States and there's a lot going on over there as well with regards to contractors. So again, employed consultant reduces that risk. So anybody does have any questions on Vertex Agility and what we do, then please feel free to drop me a message and I'll answer as best as I can. As a bit of an overview for those who didn't attend part one, what we done in the first session was kind of an overview of the possibilities of what can be done with Kubernetes for machine learning. For those who haven't seen that, obviously ping me and I can get the recorded version across to you. We also have the slide shares for that. Part two is going to be hosted obviously by Jake, who we've got on the call now, and it's going to be more of a technical dive into Jupyterhub and then how it can be used with Kubernetes in the cloud. So yeah, on to you, Jake.
Cool, thanks very much. So hello everyone. This is, as Danielle said, the second part of the Machine Learning Kubernetes series, and this is about developing in the cloud with Kubernetes and particularly Jupyterhub. So first of all, a bit about myself. So my name is Jake. I live in London in the UK, and I'm 27 years old. And my hobbies are traveling around and also playing video games. More importantly, I've been working with Vertex as a DevOps consultant for about 2.5 years now, and I've been doing Docker-based setups for about 5 years and using Kubernetes since about version 1.5, which is about 3 years ago. And since becoming a consultant, I've been working with both large multinational enterprises and startups, doing both DevOps as well as front-end and back-end development using things like Angular, MongoDB, PostGIS, Heroku, so quite a lot of technology and tools experience. So what we're going to talk about today, so first of all, we'll take a look at what the Jupyter project is for any newcomers that aren't aware of it. Then we'll move on to what Jupyterhub actually looks like when it's deployed and running on Kubernetes in an optimized environment. And lastly, we'll tie that all together by discussing why you should be using it and pointing out some of the benefits and the drawbacks. Okay, so what is Jupyterhub? So a brief history. It all started out with IPython in 2001. So Fernando Perez at the University of Colorado Boulder, he wanted to combine a bunch of different ideas from a few different projects that were around at the time. And the goal was to create an interactive Python development environment. And that interactive environment is now a key part of Python today. So if you download and run Python just on its own without any files, you'll get that interactive REPL-like environment where you can type in commands and get the output straight away. And then more than a decade later, there was the Jupyter project started. And the goal of that was to bring that same interactive experience, but wanted to bring it to some of the new languages that were being used in science and academia. So in particular, there's R, Julia, and Scala. And also quite important was the web technologies were becoming quite mature at this point. So they want to make all this happen in a web browser using a web app rather than using a terminal like with IPython. And then the year after, there was the Jupyterhub project, which is under the same family as the Jupyter notebooks. And that was started to bring Jupyter notebooks to the cloud. And that has contributions from all the big cloud players that you probably know, like Amazon, Netflix, Google, Microsoft. They all contribute code and documentation, as well as using it themselves in their organization. So Jupyter itself, the main goal is to enable data scientists to write code and generate visualizations of data side by side within the same interface. And they use many libraries to do this. There's plenty available, and they can generate things like graphs, maps, tables, anything really you can think of. And the important point here is that because the code and the visualizations are side by side, you can then rerun that code on new or updated data to recreate and update the visualization. And then Jupyterhub, the goal of that is to wrap the Jupyter notebooks to make them cloud native. So it does things like adding authentication with enterprise systems like Active Directory or Google G Suite, as well as public development tools like GitHub. It adds workspaces for multiple users, so that allows them to share the same compute environment and then can scale those workspaces on demand. And it also comes with built-in cloud best practices for security. So for example, blocking the cloud metadata service, which is quite common on cloud providers, which can be useful, but can also leak implementation details to hackers. Okay, so let's dive in to see what Jupyterhub looks like. And for this, we'll be going through a video demo. I'm not brave enough to do this demo live, so it's all pre-recorded. So first thing to notice is that we'll go to Jupyterhub on a HTTPS endpoint on our own domain, so we know it's all genuine. And then we get a login screen, and this is going through my company's authentication domain using, in this case, Google G Suite, but it could be, as I said, Active Directory or any other common authentication methods. And then we get to here. This is kind of the main hub of Jupyterhub. And so here we can choose between different profiles, and data scientists can choose different profiles based on their use cases, what they're working on at that time. So these profiles contain things like the amount of different amounts of CPU and memory, or even a GPU. It can also change things like the language environment. So you can see here we've got R and Python environments to choose from, but you can create your own just by creating a Docker image. And you can also choose things like the pricing model that you use for your cloud environment. So as you can see here, we've got either spot instances on AWS or on-demand instances, and we'll go into that a little bit more in just a few moments. So let's choose the extra large environment, which is a Python environment with spot instances. And then once we click the spawn button, what you'll see is Jupyterhub goes away to the Kubernetes cluster and creates a new pod or a container on the cluster. And Kubernetes reacts to that by saying, oh, I need to scale up my nodes so that I can run that workload. So you can see here, if we switch to the AWS console, you can see that we get a new spot request and then a new EC2 instance of VM startup. As you can see here, we've got two VMs running currently. These are the running Jupyterhub itself, which is and some load balancers, and then we get a third new VM, which is where the actual Jupyter notebook itself will run. And switching back to Jupyterhub, you see that we get a nice progress bar and also some debug information to give us an update of what's happening. And then this is sped up, but after a few minutes, Jupyterhub will have successfully started the notebook for you. And then we get taken to the file browser. So just to talk quickly about spot instances, like I mentioned, so this is one of the easiest ways to save money for your compute costs. You can save about 2/3, as you can see here from this graph. We're paying just over 7 cents instead of 22 cents for our EC2 instance. But you can actually, in some cases, save up to 90%. So the costs that you could save is potentially quite substantial. So this is spot instances on AWS, but there are also similar schemes available on Google Cloud as preemptive instances, and Microsoft Azure has low priority instances, which again have this same idea where you trade the availability of your VM over the cost. You can mitigate that risk of low availability. For example, like on the graph, you can see for this particular instance type and instance size, you can see that there has been no problems with availability. So we should have the instance continuously for the last 3 months if we wanted to. The other thing you could do is have an additional profile in Jupyterhub to use a on-demand instance, which then means you're guaranteed for that to have the availability of that instance. As we saw in the profile switcher, that's just a couple of clicks of a button. Or indeed, if you have an SRE team for your cluster or for Jupyterhub specifically, they will be able to create alerts and monitoring for that situation, and then just do that transparently behind the scenes, no action needed from the users. So now we'll move on to see what a Jupyter notebook actually looks like when you start it up. So if we switch back to the file browser, you can see that we have, so here I've downloaded some open source example notebooks just from GitHub. There's plenty of them available, and there's a great list on the Jupyter website if you'd like to take a look yourself. So this one is about Euclidean space and vectors. So here we'll rerun the code, and you can see the visualization, the graph has been regenerated. And just to prove that it isn't actually regenerating it, we'll change the title in the code, and you can see that the title of the graph does update. And then the last thing to show off is shutting down. So at the end of the day, when you finish your work, the user can just go to the stop button here, and there is a mechanism in here in Jupyterhub to automatically detect idle servers. So if the data scientist does forget to manually click the button, then it does eventually time out once they close their browser down to trigger the same behavior. And what you'll see is Jupyterhub has destroyed that pod on the Kubernetes cluster. And then after a few minutes, the Kubernetes cluster reacts by saying, okay, I don't need that VM anymore. I'm going to delete it. As you can see here, the middle VM that we created to host the workload has now been completely deleted and stopped, which means that it's no longer costing us any money. So what this means is overnight or at weekends, outside of business hours, you're not paying for any compute capacity that you're not using. So you can save a lot of costs that way as well. Okay, so just to summarize what we just saw in the demo, we went to a HTTPS endpoint with an automatically renewing certificate. We signed in with our company's directory, including multi-factor authentication. We were able to choose our own instance size, the language type, and any drivers and libraries that we needed to fit our use case using the profile switcher. The cluster automatically reacted by scaling up the worker instances and all our files were persisted to disk so that we can be so that it can be used in a future session. So let's get into a bit of the nitty-gritty now. We'll talk about why you should be using Jupyterhub on Kubernetes. So we'll go through some of those features and talk about why they're useful and why you should care about them. So we'll start with talk about security. So as I just mentioned, we had a HTTPS endpoint with fully automated TLS certificate management. So the classic scenario is that your operations team will have to set a recurring appointment in their calendar every year or maybe every 3 years to go and renew all your TLS certificates for you and manage all those private keys, keep them somewhere safe. No need to do that in the cloud today. All that gets handled for you, and indeed you can't actually access the private keys even if you wanted to. We saw signing in with our enterprise grade directory, so that could be Active Directory, Google Apps, like we said before. What this means is that you can force your users to obey your password policy, so they won't be able to create a weak password, and if you have password reset facilities, maybe through an IT help desk, then all that gets tied in as well. And you can also enforce multi-factor authentication, so you can prevent phishing as well as leaked or weak passwords. Your runtime environment that we created through the profile switcher is fully declarative. What that means is the biggest benefit of that is that your environment becomes fully auditable. So all the environment is defined as code using Docker files, and you can just go back through the history of that Docker image and see what libraries installed, what packages are installed, the versions they're at, which drivers are installed, and update them as needed. And lastly, there's no sensitive data gets stored on your employees' laptops. So one of the big risks is that you have all this sensitive data on your laptop, and then that laptop gets maybe lost or stolen, maybe on the way home from work or something. If that happens with this model, the thief still has no access to any of your customers' data, which may include things like personally identifiable information, because they still need to have the username, password, and potentially the two-factor authentication device. We'll talk next about costs. So we saw in the demo that the VMs are automatically shut down by Jupyterhub and Kubernetes after they become idle. So like we said, outside of business hours, you're not paying for that expensive compute capacity, just the disks. Similarly, you can scale up and down your instances vertically, simply by just clicking in that UI self-service. So if, for example, a data scientist is testing a machine learning model on a reduced data set, they can scale down their instance to a smaller, maybe burstable instance, which costs the company less. And then when they're ready to move on to a production data set, then they can scale the instance back up and run that same model much more quickly on a bigger machine. We also saw and talked about spot instances, and again, they're available across pretty much all cloud providers these days, and is a very easy way to save up to 90% of your costs. And lastly, you can save a lot of money by not needing to buy powerful local workstations, so laptops or computers, because all that data processing is happening in the cloud. So you can just buy kind of a standard laptop, if your company is using a fleet of Windows machines, for example, then that's no problem, because all they require is a modern web browser, so they can use Windows, Mac, anything they want. We'll talk a little bit about scalability. So we can see that you could scale your workbooks, workspaces vertically, so you can add more CPU, memory, and things, cloud-specific devices like TPUs on Google Cloud in just a couple of clicks, and then scale back down to either 0 or a smaller instance. You can share your compute resources between workspaces. So we didn't see this in the demo, where in the demo we were using a dedicated VM per workspace. But actually, you can share workspaces. Share a VM. So many workspaces sit on one VM, and that can be quite good because users are quite rarely using 100% of that compute capacity on the VM. They might be, looking at results of a previous run or writing some more code. So that idle compute capacity can essentially be donated to other workspaces, which lets them complete their work faster. And lastly, of course, Jupyterhub can scale horizontally, like most cloud-native systems. So Jupyterhub is split into different microservice components, and each of those components can be scaled up and down individually. So that means you can go from just a few data scientists working on a cluster to potentially hundreds. So availability, this is an important part of business continuity and also security. So you can use cloud-native technologies built into the cloud providers to replicate your data across data centers or indeed whole regions around the world. So things like S3 bucket replication on AWS, Cloud Spanner on Google Cloud gives you a multi-master database, or there's open source projects like Ceph. And once that data is spread around different data centers, it's very easy using Kubernetes to move your compute capacity around. So as long as you have a Kubernetes cluster running in your new region, then you can easily deploy your workloads onto that Kubernetes cluster and get up and running very quickly. You can also use projects like the Kubernetes Federation project, which essentially lets you run multiple clusters at the same time with a global control plane over the top. And so what this means is that you can write specific rules, which means that your workload can be deployed to different clusters dynamically. So for example, I could have a workspace where I prefer to work in the European cluster because that's closest to me and it'll be faster. But if there are availability concerns or there's more capacity in, say, North America, then that's perfectly fine as well. But never use Asia because that's too far away, for example. And you can also, another important point is staying compliant with data regulation. And there's plenty of cloud tools that will help you use that, including ones built into the cloud providers themselves. For example, AWS has a backup and restore service. And then lastly, just as important as keeping your systems running is keeping bad actors out of them. So there's lots of tools that can and techniques that can help here. So for example, IP firewalls and whitelisting to whitelist specific offices or devices. You can use mutual TLS authentication to authorize specific end user devices, or you can use web application firewalls to inspect the web traffic itself and look for attacks like SQL injection or cross-site JavaScript attacks. And then lastly, we'll talk a little bit about consistency of environments. So a key part of DevOps is making sure that your deployments are repeatable. And because you're using Kubernetes, that is basically baked in from the get-go. So as we said before, those images are defined as code in Docker files and can be completely audited. And then every new environment is launched fresh from that golden template image, so you know exactly what is running. If you have existing Kubernetes clusters or SRE teams, then you can make use of those resources when using Jupyterhub. For example, lots of skills are transferable between SREs and developers for machine learning, and you can also tightly integrate your applications and the machine learning flows. So for example, if your application customer data and your training model are residing in a similar place, you can get performance benefits by looking at the same disks, for example. And also, quite interestingly, is you can save, again, some money and compute resources by using the idle application servers to do batch processing. So, for example, if you scale down your web application overnight or over the weekend, you can then run batch processing like training models or other kinds of processing overnight on that spare compute capacity. And then lastly, we'll talk, there's the onboarding of new employees. So the typical scenario is you get a new data scientist employee, you provide them with a laptop, and then they have to spend days, maybe more, setting it all up, downloading Python, downloading all the libraries, installing the drivers that they need, installing IDEs, all that kind of stuff. With Jupyterhub, there's no need for any of that. All they need to do is launch the web browser, log in, and in a couple of clicks, they have that environment ready to go. They can start being productive in less than an hour instead of less than a week. So all that sounds pretty cool, but it's not a perfect scenario, of course. One of the big problems is that these Jupyter workspaces are designed for one user at a time. So that makes it a bit harder to collaborate, especially when you're running the models themselves. Typically, that collaboration needs to happen outside of Jupyter, so in tools like version control systems like GitHub or GitLab. If all your data is kept locally, for example, like a private data center in your office, then you're going to have to do a lot of transferring up and down to and from the public cloud. There are ways to mitigate this. For example, if you buy a private link, which can increase bandwidth and transfer speeds, or you could just go ahead and set up a Kubernetes cluster in your private data center itself. The disadvantage there, of course, is that you don't get the elasticity and flexibility of the public cloud. You'd have to still buy and maintain your own hardware. Another problem is that Jupyterhub is still not a perfect abstraction away from Kubernetes. So we saw in the demo, there was that event log, which gave you lots of good information for debugging, maybe if you're an SRE. But if you're a user who doesn't know anything about Kubernetes, then that looks a bit scary, full of jargon, doesn't really make much sense. And what that really comes down to is that Kubernetes is still quite difficult to use for both operators and users. It is getting better. Over the last few years, we're getting more and more managed services. So we've had AWS EKS and Azure AKS. Obviously, Google GKE is probably the best known one. And then also some of the smaller players like DigitalOcean are also releasing managed Kubernetes products now. But still, getting started is still relatively difficult, and there is a steep learning curve to learn not only all the new terminology, but also to change your way of thinking when building distributed systems and cloud-native applications. And I guess all that can be summed up with, you get, Kubernetes gives you lots of power, lots of flexibility, but there's also lots of ways that it can go wrong, unfortunately. And I think that's pretty much it. If anyone has any questions, then we'll be happy to answer them.
Cool. Some of you should be able to speak now. What I've done is allowed talking. So I think you just have to unmute your mic if you've got any questions. If not, feel free to just drop something in the chat section. You know, otherwise, obviously Jake and myself can be contacted. I'll ping you all a little bit of a note afterwards, just so that you've got both mine and Jake's contact details if you've got any questions. The video recording of this will be available in a couple of days, and if Jake, you want to ping me over the slide share, then obviously I'll get that shared out to everybody too. I've just noticed a message from Akhan too. He just asked obviously if you can send references for setting the setup on Kubernetes, Jake.
Yeah, I can. So all this, I don't think I mentioned before, but all this is built with open source tools, and the demo was done on AWS using EKS managed services. So yeah, all that is defined as code, and I can send that over with the slides. Cool.
Okay. Cool. Well, yeah, thanks for that, Jake. It was really interesting. Hopefully that was useful to everybody else as well. As I said, I will drop everybody over a link to the recording when it's done. Any other questions, ping me or Jake, and yeah, we'll get them answered. Cool. Cool. All right then. Thanks everyone. Thanks, Jake.
No problem. Thanks everyone. See ya.
Cheers. Bye.